In today's tutorial we will have a look at a reaction where we have a four-component mixture. We have benzaldehyde A, we have this enamine B, we have this tertiarybutylamine C, and we have 0.1 equivalents of acetic acid. So, if we want to anticipate what will happen, we can say, well, let's look for the electrophilic and the nucleophilic centers. What about benzaldehyde? Well, it's partially positively polarized here. This carbon is an electrophilic center, and we just write down a delta plus at this position. This component, an enamine, is clearly nucleophilic. If we would try to protonate it, it will always be protonated here at that carbon, because then we have a conjugated stabilized cation, and therefore we place the delta minus here at that carbon. Easy is that amine, free electron pair, delta minus. And here, what about the electrophilic centers of the acid? The most electrophilic center simply is that proton. It's an acid, and it will protonate, delta plus. So let's think about what is the strongest nucleophile here in this mixture. It's compound C. And what is the strongest electrophile? Well, it's that proton here, compound D. C plus D will give a salt, an ammonium salt with ammonium acetate in equilibrium. Well, now what is the second electrophile? Here, this aldehyde. So C will also react with A, making a condensation reaction, and present is of course still acetic acid. So the condensation reaction will form an iminium cation, of course with the acetate counter an ion, and condensating water is formed. In equilibrium, this imine can be set free, and again the catalytic amounts of D. This has here, of course, an electrophilic center, but if it's protonated as here, then it's even more activated, and it's a stronger electrophilic center here compared to the charge-free imine. Since this is then a very strong electrophile, we should have a look, where are the nucleophiles? Well, we have again still some C in there, could react in. An aminal is the result, a reversible aminal formation, but we have still not made use of component B, with enamine, with the nucleophilic center here. So let's have a look. E should react with B. What happens? This is the nucleophilic center, this is the electrophilic center. If we form a bond in between, then this is the result, this iminium cation, still acetate counter an ion. In equilibrium, it can be deprotonated here, then acetic acid D is formed again, and this enamine as the first good isolable product, well, we should call that it's a product of a Mannich reaction. If we form an iminium cation that reacts as an electrophile either with an enolate or with an enamine, we call that a Mannich reaction. So, but there can be some subsequent reactions. We have water formed in this condensation process, and this water could also be used for hydrolyzation of that enamine. Then morpholine would be formed and this ketone, and if we let the reaction run for a longer period, then of course also an elimination could take place again here. Well, it's both are equilibrium reactions, and C is formed, and this alpha beta unsaturated ketone. Thanks for listening.